All right, take a look around you. I'm talking about your mouse, your keyboard, maybe the water bottle sitting on your desk, even parts of the car you drove today. They're all plastic, right? And they're everywhere. But they're not just everywhere. They're perfectly formed, and there are millions of them. So, how? That's what we're going to break down right now.
I mean, really think about that for a second. How on earth does a factory churn out 1,000,000 keyboard keys that are all absolutely identical, or soda bottles that are flawless, one after the other? The secret? Well, it isn't really the plastic itself. It's the hidden marvel of engineering that gives it its shape.
And here it is. This is the hero of our story, the plastic mold. You have to understand, this isn't just some bucket you pour plastic into. It's a high-precision tool, an industrial architect that's responsible for giving just about every plastic product its final, exact form. I mean, without the mold, all you've really got is a useless puddle of hot goo.
So, at its core, a mold is actually pretty simple in concept. It's made of two main parts. You've got a fixed half and a moving half. Honestly, the best way to think about it is like a super high-tech waffle iron. The two halves clamp together, and that creates an empty space inside. We call that the cavity, and that cavity is the exact negative shape of the part we want to make.
Okay, so we've got the mold. Now what? How do we actually get the plastic into that cavity? Well, the most common method by a long shot is a process called injection molding. This is the absolute workhorse of the plastics industry, creating a huge range of the products we use every single day.
The whole thing works in this beautifully efficient cycle. First, a massive machine clamps those two mold halves together with incredible force. Step 2, molten plastic gets blasted into the cavity under really high pressure. Third, and this is crucial, the plastic just has to cool down and harden, taking on that perfect shape. And finally, the mold pops open and little ejector pins push the finished part out. Then boom, it closes and the whole cycle starts over, sometimes in just a few seconds.
But get this, out of that whole cycle, what do you think takes up the most time? It's the cooling. It's not just a pause, it is the most critical phase. Sometimes up to 70% of the entire cycle is just waiting for the part to cool properly. And why? Because if you rush this step, the part can warp or have weak spots. Getting the cooling just right is the key to a high-quality product.
So we know injection molding is king, but it's not the only game in town. See, different kinds of products with different shapes and jobs need totally different kinds of molds and processes. You can't make a water bottle the same way you make a keyboard key.
And that specialization is really important. Injection molding, as we saw, is perfect for solid, complex shapes like a TV shell. But for something hollow, like a drink bottle, you need what's called blow molding, where they basically inflate a tube of hot plastic like a balloon inside the mold. And then you've got extrusion molding, which is for creating long, continuous things like PVC pipes or window frames by just pushing plastic through a shaped opening. Every product really has its own perfect tool for the job.
So now we get the basic processes. But what's the difference between a cheap mold that breaks after a few thousand uses and one that can flawlessly produce millions of parts for years and years? Well, that's where we get into the incredible science and precision engineering behind making the mold itself.
It all boils down to this one simple truth. Your plastic part will only ever be as good as the mold that made it. That's it. The design of that steel tool dictates everything. How the product looks, how strong it is, and even how efficiently you can make it.
And to get that quality, you have to start with the right material for the mold, usually a very special kind of steel. And the requirements for this steel are just intense. Think about it. It has to be workable enough to be machined into incredibly complex shapes, but also hard enough to not wear out after millions of cycles of heat and pressure. It needs to be able to be polished to a mirror finish, and sometimes it even has to resist being corroded by the very plastic it's molding.
This is where the engineers have to make some really tough choices. It's a total balancing act. You see, for a small production run, say under 200,000 parts, a softer, cheaper steel like P20 is totally fine. But if you need a mold that's going to last for over 1,000,000 shots, you have to invest in a seriously hard, super durable, and much more expensive steel like S136. So picking the right steel isn't just a technical decision, it's a huge economic one too. So when you put all of this together, the design, the process, the material science, you really start to see the plastic mold for what it is. It's this silent, absolutely essential architect of our modern world.
It really is the unseen architect. Every single precise curve, every tiny logo, every little clip on countless products, it only exists because an engineer painstakingly carved that detail into a block of steel.
The mold is the physical bridge that takes a raw idea and turns it into a physical reality that can be copied millions and millions of times.
So I'll leave you with this thought. The next time you grab your phone case, or even just a simple bottle cap, give it a second look. Are you going to see just a piece of plastic? Or are you going to see the invisible signature of its creator, the complex, perfectly engineered steel molds that gave it life?